Students, place a white paper on a drawing board and place a bar magnet in the middle of the paper. Sprinkle some iron filings on it. Tap the board gently. What do you observe? You must have seen a transformer on a road, electric doorbell or ding-dong, speaker, electric water pump, generator, radio, television antenna. Have you ever thought about the working? The answer is electromagnetism. Look at the picture. Sharp and heavy iron scrap material is attached to a big disc. The disc is a magnet and all scrap is attracted to it. This process is used in loading and transporting scrap and loose iron material in a steel mill. It is not feasible to create a permanent magnet of such a big size and store such a big magnet. Therefore, magnetism is induced in the disc with the help of electricity. Such a magnet is called electromagnet. Let us perform this activity. Take a drawing board and fix a white sheet of paper on it. Place a bar magnet at the center and draw its outline with the help of a pencil. Place the magnetic needle close to any pole. Wait till the needle comes to rest. Draw the dots with pencil as shown. Go on marking till the needle comes to the other end or pole. Draw a smooth curve using dots. Repeat the process to plot other smooth curves as shown. Let us see what is meant by magnetic lines of force. The path along which the unit north pole moves in the magnetic field is called magnetic lines of force or magnetic field lines. Properties of magnetic lines of force. 1. Magnetic lines of force are closed continuous curves. They start from north pole and ends on south pole. 2. The tangent at any point on the magnetic lines of force gives the direction of the magnetic field at that point. 3. No two magnetic lines of force can intersect each other. 4. Magnetic lines of force are crowded where the magnetic field is strong and far from each other where the field is weak. Let us try out this activity. Make the circuit by connecting the two terminals of the electric cell to the key as shown. Place the compass needle close to it. Note the direction in which compass needle is pointing. While watching the compass needle carefully, close the key for few seconds. Release the key and watch again. Repeat the steps again by changing its polarity. In the above activity, it is observed that the needle gets deflected when we press the key. If the polarity is reversed, the needle gets deflected in the opposite direction. Thus, if a current is passed through a wire, electric field is produced near it. This was discovered by the scientist Ørsted. He showed that electricity and magnetism were related phenomenon. Danish physics professor Hans Christian Ørsted was doing experiments with some electrical equipment. He saw that when he passed strong electric current through a wire, a nearby compass needle got deflected. Ørsted realized that the electric current was producing magnetism. A compass needle is a small bar magnet. The ends of the compass needle point approximately towards north and south directions. The end which points towards north is called as North Pole or North-Seeking Pole. The end which points south is called as South Pole or South-Seeking Pole. Like magnetic poles repel each other and unlike poles attract each other. Let us do this activity. Take a battery of 12 volt, a variable resistance or rheostat, an ammeter of 0 to 5 amperes, a plug key, needle and a long straight thick copper wire. Take a rectangular cardboard, pass this wire through the center. Take care that the cardboard is fixed and does not slide up or down. Make the arrangement as shown. Sprinkle iron filings uniformly on the cardboard. Close the key and tap the cardboard gently. Observe the pattern of iron filings. What will happen if the current is increased? More magnetic lines are produced. Also observe the needle if it is moved away from the wire. The number of magnetic lines decreases.